The Neanderthals were a European species. Their bones come out of European ground, a German valley, a Spanish cave, a French rock shelter. They lived there, they adapted to that cold, and 40,000 years ago, they died there. So when geneticists began measuring how much Neanderthal DNA survives in living people, the expected result was not complicated. The people living on top of the Neanderthal homeland should carry the most of them. They do not. The population carrying the most Neanderthal ancestry lives about 5,000 miles east of the last Neanderthal, in a part of the world where Neanderthal remains have never been found at all. Europeans are not first. They are not second either, depending on how you count. For years, nobody could explain that. The answer arrived in 2023, and it has almost nothing to do with Neanderthals. There is a detail in that opening worth holding on to, because it changes what the whole ranking means. The Neanderthals did not simply die out and leave a gap. Their population thinned over thousands of years, and in the same period, they were meeting modern humans and having children with them. When the last recognizably Neanderthal groups disappeared around 40,000 years ago, a portion of them had already moved across into a population that was growing rather than shrinking. Which is why the phrase extinct species fits them badly. Extinct in the ordinary sense means the line stopped. Their line did not stop. It was absorbed. There are more Neanderthal DNA segments alive today, spread across billions of people, than there were when Neanderthals were a living population, with their own camps and their own dead to bury. So the ranking we are about to go through is not a list of who has the most residue from a failed species. It is a list of where the surviving pieces ended up. And the geography of that turns out to be a story about the last 10,000 years, not the last 50,000. Start with the number everyone quotes. Across Eurasia, Neanderthal ancestry averages around 2% of a person's genome, about one line in every 50 of your genetic instructions. 2% is the headline, and it hides the interesting part, because that figure is not evenly spread. When you separate the populations, people of East Asian ancestry come out consistently higher than people of European ancestry. The reported gap runs from about 8% more to about 24% more, and it is usually summarized as around 20%. Put that at human scale. For every 5 Neanderthal segments a person of European descent carries, a person of East Asian descent carries about 6. That is not a rounding error, and it is not one study having a bad day. It has been replicated across different datasets and different methods for over a decade. The gap is real, which leaves the question of how a European species ended up better preserved in Asia. Before going further, it is worth knowing what that percentage actually is, because it is not what most people picture. Nobody is counting Neanderthal genes in you, because there is no such list to count from. What researchers do instead is look for stretches. When two populations interbreed, the incoming DNA arrives in long, continuous blocks, and every generation afterwards, those blocks get cut shorter as chromosomes shuffle. 50,000 years of shuffling leaves short, scattered segments, but they are still recognizable because the pattern of variance inside them matches the Neanderthal genome and does not match the range of normal human variation. So the software walks along a living person's genome, asking, segment by segment, whether this stretch looks more like the sequenced Neanderthal than like anything found in populations that never mixed with them. Add up the stretches that pass, divide by the length of the genome, and that is your percentage. 2 consequences follow, and both matter for a ranking. The figure is an estimate with error bars, not a count, and it depends on the reference data, which is why different companies hand you slightly different numbers from the same spit. With that in hand, the gap between Europe and East Asia is still there, so the explanations began. The first explanations were reasonable, and all of them ran into the same wall. Perhaps there was simply a second, separate mixing event in Asia, modern humans meeting a different group of Neanderthals further east, topping up the inheritance. There is some support for extra pulses of mixing, but the effect is not large enough to carry a 20% gap on its own. Perhaps natural selection did it. Neanderthal DNA has been under pressure ever since it entered our genome. some of it useful, some of it harmful, most of it slowly removed. If selection pushed harder in Europe than in Asia, the European figure would fall, but the models keep coming back, saying the pressure was broadly similar in both places. It is not enough, and there was a third detail sitting in the data that nobody could make useful at the time. European hunter-gatherers, the people who lived there before farming, carried a noticeably higher proportion of Neanderthal ancestry than Europeans do today. For a while, that looked like a curiosity about ancient bones. It was the answer, because the question everyone was asking had a hidden assumption in it, and the assumption was the problem. Everyone, including the researchers, was asking why Asia gained Neanderthal ancestry. The measurement does not actually say that. It says there is a gap. A gap can open because one side climbed, or because the other side fell. Nobody had seriously asked whether Europe lost some. And once you ask it that way, you need to know what happened to Europe's population after the Neanderthals were gone. Not 50,000 years ago, when the mixing happened. Much more recently, in the window where the continent's ancestry was rearranged from the outside. For most of the period after the Neanderthals disappeared, Europe belonged to hunter-gatherers. They lived there through the last ice age, and out the other side, in small mobile populations, for tens of thousands of years. Their descendants carried the Neanderthal inheritance forward, and they carried a lot of it. It is worth being concrete about who these people were, because most of us have no picture of them at all. The best-known individual is a skeleton found in a cave in southwest England, about 10,000 years old, known as Cheddar Man. In 2018, researchers recovered enough DNA from him to make a reasonable estimate of his appearance, and the result was not what the popular image of an ancient Briton had ever suggested. The genetic markers indicated dark skin and blue eyes. That combination sounds contradictory only because we have absorbed the assumption that pale skin came with the territory. It did not. Pale skin in Europe spread later and spread substantially with the very population we are about to discuss. Cheddar Man's people had been in Europe for thousands of years already, and they looked nothing like the continent's later inhabitants. Those are the people carrying Europe's high Neanderthal fraction. Not a vague prehistoric backdrop, a real, sequenced population, with faces we can now partly reconstruct. And then their continent was resettled. Then, roughly 10,000 years ago, something arrived that changed the continent more than any invasion in recorded history: farming. It did not spread as an idea, it spread as people. Populations who had domesticated crops in Anatolia and the wider Middle East moved into Europe carrying their agriculture with them, and they kept moving, generation after generation, across the whole continent over thousands of years. 10,000 years is roughly 400 generations. They did not replace the hunter-gatherers entirely. They mixed with them. Modern Europeans are the result of that mixing, plus later arrivals. And here is the thing about those farmers that matters more than anything else in this video. They carried less Neanderthal DNA than the hunter-gatherers already living in Europe. So run it forward. You begin with a European population rich in Neanderthal ancestry. Into it moves a large, expanding population carrying less. They mix for thousands of years across the entire continent. The arithmetic is not complicated. Blend a population that carries more with a population that carries less, repeatedly, over 400 generations, and the average comes down. That is what happened to Europe. The Neanderthal signal was not destroyed, and it was not selected away. It was diluted by farmers. East Asia had no equivalent event in that window. No comparable wave of outsiders carrying a lower Neanderthal fraction moved in and mixed across the region on that scale. So East Asia kept more of what it started with. The gap was never Asia climbing. It was Europe coming down. The farmers were not the last arrivals, which is the part that turns this from a single event into a pattern. Around 5,000 years ago, roughly 5 millennia after the farmers, a third population moved into Europe, herders from the steppe grasslands north of the Black and Caspian Seas. They came with horses, with wheeled vehicles, and with a pastoral way of life, and their genetic impact on Europe was enormous. In parts of northern Europe, the turnover was drastic enough that a large fraction of the existing ancestry was replaced within a few centuries. So the ancestry of a modern European is not one population at all. It is a layered mixture of at least three: the original hunter-gatherers, the Anatolian farmers, and the steppe herders. Most Europeans alive today are the result of all three, in proportions that vary by region. That is the real difference between the two ends of Eurasia in this story. Europe is a continent that was substantially resettled, twice in the space of a few thousand years. Each wave brought in a large population and blended it with what was already there. Every one of those blendings averages the Neanderthal fraction with a new set of numbers. Keeping a high proportion of anything through two continental resettlements is close to impossible. East Asia's story over that same window was less dramatic in this particular respect, so the number there is not really higher. It is less reduced. Sit with the shape of that for a moment, because it inverts the entire question. The reason Europeans carry less Neanderthal DNA than East Asians has essentially nothing to do with Neanderthals. Nothing to do with who met them, or how often, or how well the inheritance worked. It is about a farming migration that happened 30,000 years after the last Neanderthal died. The percentage on a European person's results page is not really a measurement of their relationship with a lost species. It is a measurement of how thoroughly their continent was resettled by farmers in the Neolithic. You are not looking at how much Neanderthal is in a population. You are looking at everything that happened to that population since, which is also why the ranking has to be read carefully, because a number that goes up and down with migration is a record of movement, not of merit. Nobody's ancestry is better preserved because they are better. Europe got farmers, and Asia did not. There is one more correction to make before the ranking is honest, and it is one the textbooks got wrong for a decade. For years, the confident answer about people of purely African ancestry was that they carried no Neanderthal DNA at all. Zero. The interbreeding had happened after the migration out of Africa, so the populations that stayed were untouched. That is false, and the correction matters for a ranking video more than anywhere else. People of African ancestry carry small amounts of Neanderthal DNA. The main route is not a separate mixing event with Neanderthals in Africa. It is that populations carrying Neanderthal ancestry moved back, returning to Africa over thousands of years and bringing the inheritance with them. The clean line the 20th century drew, the one where some populations are archaic free and others are not, does not exist. It is a matter of proportion, everywhere, in everyone. And once you accept that the question is proportion rather than presence, the ranking has one more surprise in it, because we have been counting the wrong species. Neanderthals were not the only archaic human our ancestors met. There was a second population, the Denisovans, and the way they were discovered has no real precedent. They were not found as a skeleton, or a skull, or a burial. They were found as a fingertip bone, a single fragment from a girl's little finger, recovered from a cave in southern Siberia. It was small enough to sit on a coin. Nobody looking at it could have told you it belonged to anything other than a human child. The DNA said otherwise. When it was sequenced, it matched neither modern humans nor Neanderthals. An entire population of archaic humans had been identified from a piece of finger before anyone had any idea what they looked like. That remains close to true today. There is still no complete Denisovan skeleton. We know them mainly through a handful of fragments and through their genetic trace in the living, which is a strange position for science to be in, because it means we can measure their contribution to modern people far more precisely than we can describe their bodies. Their DNA is concentrated in Asia, the Pacific, and Australia, and in Papuan and Melanesian populations, the Denisovan share reaches several percent, higher than any population's Neanderthal figure anywhere on Earth. So if the question is, who carries the most Neanderthal DNA, the answer is East Asian populations, by around 20% over Europeans, for reasons that come down to farmers. But if the question is, who carries the most archaic human DNA, the most inheritance from extinct relatives of any kind, then the answer is not in Europe or East Asia at all. It is in New Guinea and Melanesia, and it is a species most people have never heard of. And that inheritance is not idle. The variant that lets Tibetan populations live and work at altitudes that make most visitors ill, came from Denisovans. A population that vanished before recorded history is the reason people can live on that plateau today. So the league table, honestly stated, looks nothing like the one people expect. Europeans, living on the ground where Neanderthals evolved and died, sit below East Asians, because farmers walked into their continent and blended the number down. People of African ancestry are not at zero and never were. And the population carrying the largest archaic inheritance of all is in the Pacific, carrying a different extinct species entirely. Every one of those numbers is a migration record. Who moved, who arrived, who mixed, and who did not, which creates the problem this whole field is now sitting on. Every number in this video is a population average, and populations are not people. Being of East Asian descent does not mean you personally carry more Neanderthal DNA than a specific European person. The individual variation inside any group is wider than the gap between the groups. Your own results page gives you one figure with no context for it at all. It will not tell you whether your number is high or low for your ancestry. It will not tell you which segments you have, and it will certainly not tell you that the number partly reflects who farmed your ancestors' land 10,000 years ago. The science has worked out what the ranking means. The product on your desk has not caught up. If a percentage can be moved that much by a migration 30,000 years after the fact, it is worth knowing what those inherited segments are actually doing while they sit there. The pain threshold, the body clock, the immune system that argues with pollen every spring. That is the companion to this one. And tell us your number and your ancestry in the comments. The pattern in this video is a population average, and I would like to see how messy it looks in a real comment section. Pinned comment for the metadata step. What's your Neanderthal percentage and your broad ancestry? The published gap is about 20% between East Asian and European averages. Let's see whether this comment section reproduces it or embarrasses it.